We will start in 2 minutes. Okay, so let us start. The first question is, xt is positive rectangular paths from -1 to +1. From -1 to +1. From t is equal to -1 to t is equal to +1. Fine. So how will it look like? It is looking like okay, this is 1 -1 +1. This is xt. This is t. Find the value of someone is trying to enter. Find the value of -infinity to +infinity. x omega square d omega. Okay, so this is our question. First, we have to understand the question very closely. Look, xt is given. It is a rectangular pulse, positive rectangular pulse, whose value is 1 from my t is equal to -1 to t is equal to -2. Right? Now we have to find the value of -infinity to +infinity mod of x omega squared d omega. Now, what is mod of x omega squared d omega? X omega is the Fourier transform of xt. Now, there are two methods we can solve. First is we will find the Fourier transform of xt. Just give me one. Okay, so there are two possible way we can solve the question. One is we will calculate the Fourier transform of xt. We will get x omega, right? And then we will proceed with this integration. What is the another way? We can use Parseval's theorem. And what is Parseval's theorem? Parseval's theorem is basically the theorem by which we can calculate the energy. So let us write Parseval's theorem. Parseval's theorem says theorem says okay, energy E is equal to minus infinity to plus infinity mod of xt square dt is equal to 1 upon 2 pi minus infinity to plus infinity x omega square d omega. Okay, so this is Parseval's theorem. Now look into this. We have to calculate minus infinity to plus infinity x omega whole squared mod of x omega whole squared d omega. So can we convert it in time domain? Yes, using Parseval's theorem. What will it be? From here we can say if we multiply 2 omega in both sides. Look, so if we multiply 2 omega in both sides and just reverse the side, we will get minus infinity to plus infinity x omega square d omega is equal to 2 pi multiplied with minus infinity to plus infinity xt squared dt. Okay, okay, so what is the value of xt? Xt is from minus 1 to 1, its value is 1, otherwise its value is 0, right? So just put the value is equal to 2 pi minus infinity minus 1 2 plus 1 1 square dt. Okay, is it understandable? Then we will get 2 pi multiplied with t is equal to minus 1 to plus 1 is equal to 2 pi 1 multiplied with 2 is equal to 4 pi. So this is the easy way to calculate the integral, right? Just using Parseval's theorem, we transform it into the time domain and then calculate the value. So you people take 2 minutes and try to understand what we have done in this. If there is any query, ask. Then we will proceed for the next question. Take 1 more minute and try to understand what we have done till now. Okay, next question. Find energy of the signal of the signal xt is equal to sine 80 divided by pi t. Okay, this is the question. We have to find the energy of this signal. So now our first task is to calculate the Fourier transform of sine 80 by pi. Can you remember that what is the Fourier transform of sine 80 pi t? It will be a rectangular pulse. So let us try to mm, solve this. Okay, so if xt is sine 80 by pi t, then sine 80 divided by pi t, its Fourier transform is Fourier transform will be a rectangular pulse. How will it look like? It will be minus a to plus a 1. Its value will be 1. So this is x omega. Now Parseval's theorem, we know that energy Energy is equal to minus infinity to plus infinity mod of xt square dt is equal to 1 upon 2 pi mod of integration minus infinity to plus infinity mod of x omega square d omega. So we can write it like 1 upon 2 pi minus a to plus a plus a x omega value is 1 whole square d omega. This is 1 upon 2 pi this will be omega minus a to plus a is equal to 1 upon 2 pi multiplied with 2a is equal to a upon pi. Fine. So this is the energy of the signal. Please take 1-2 minutes to digest and then we will proceed for the next question. Please take 2-3 minutes. Try to digest what we have done till now. If there is any query, you can ask. Then we will proceed for the next question. What we have done here, simply we know that the Fourier transform of sine 80 pi t is a rectangular pulse from minus a to plus a. This is known to us. We have solved it in previous sessions, right? So we are using this property, and from this we are calculating the energy. Energy is minus infinity to plus infinity xt whole square dt is equal to 1 upon 2 pi minus infinity to plus infinity x omega whole square dt d omega. Then we are putting the value from minus a to plus a and push it in the integration. We are getting a by pi, right? Please understand it. Okay, let's move for the next question. Find the value of find the value of minus infinity to plus infinity sin t divided by t dt. Okay, so find the value of minus infinity to plus infinity sin t by t dt. This is our question. Again, we will use the property that sin at divided by pi t. Its Fourier transform is a rectangular pulse from minus a to plus a. From minus a to plus a. Fine. This is x omega. This is omega. Fine. Now, what we know? We know, or we have, the basic definition of Fourier transform. Fourier transform, the basic definition is x omega is equal to minus infinity to plus infinity xt dt. No, sorry, e to the power minus j omega t dt. This is our basic definition of Fourier transform, right? Is anyone will agree? No? Okay. So find the value of minus infinity to plus infinity sin t by t dt. This is our question. And sin t by t Fourier transform is known to us. Now put xt is equal to sin at by pi t. Divided by pi t. Fine. Okay. So x omega is equal to minus infinity to plus infinity sine 80 divided by pi t e to the power exponential j minus j omega t dt is equal to 1 for minus a omega plus a. Fine. Is it clear? So this is the question and this is the answer what we are solving. What we have done till now, we have sine 80 by pi t Fourier transform is a rectangular function. Okay, and we have used this here. So x of omega, from the basic definition of Fourier transform, x omega is minus infinity to plus infinity xt e to the power j omega t minus j omega t dt. Now put the value of xt is equal to sine 80 by pi. So what we get? We get x omega is equal to minus infinity to plus infinity sine 80 divided by pi t multiplied with e to the power minus j omega t dt is equal to 1 for minus a omega less than plus. So this is we are getting. Now put a is equal to 1 and omega is equal to 0. So we will get x omega is equal to minus infinity to plus infinity sine t divided by pi t, and its value will be e to the power 0, that means 1 dt is equal to 1 for minus a less than omega less than plus a, and in other area it is its value is 0. Okay, fine. So we can write it like minus infinity to plus infinity sin t divided by t e to the power 0 means 1 is equal to pi. Pi will be multiplied in both sides, right? For minus a less than omega less than plus a and 0 elsewhere, or else लिखेंगे. Fine. So this is what we got. So please look into this again, take 2-3 minutes and try to understand. If there is any query you can ask, or we will proceed for the next question. Before proceeding, please take 2-3 minutes, try to digest what we have done here and ask if there is any query. Take 1 or 2 minutes and try to understand, and we will proceed for the next question. A very interesting question. Okay, so let's move to the question 4. Consider a signal. Consider a signal xt is equal to e to the power minus t for t greater than or is equal to 0 and 0 for t less than 0. Fine. Full stop. Let x omega denote the Fourier transform ft of the signal. The integral then find integral find the integral 1 upon 2 pi minus infinity to plus infinity x omega d omega. Okay, so consider a signal xt is equal to e to the power minus t greater than or equal to 0 and 0 t less than is 0. Let x omega denote the Fourier transform of the signal. Find the integral 1 upon 2 pi minus infinity to plus infinity x omega d omega. How we can calculate this? It is a very interesting question and very simple question too. Let inverse Fourier transform. If we put using the definition of inverse Fourier transform, using the definition of inverse Fourier transform, we can write 1 upon 2 pi minus infinity to plus infinity x omega e to the power j omega t d omega is equal to xt, and xt's value we know e to the power minus t and 0, e to the power minus t for t greater than or is equal to 0, and this is for t less than 0. Fine. Now put t is equal to 0. T is equal to 0, then we will get 1 upon 2 pi minus infinity to plus infinity x omega. This will be 1 d omega equal to, this will be 1 for t greater than or equal to 0 and 0 for t less than 0. Right? Hope it is clear. So in this way we can solve this problem. This is very interesting and important problem. You people take 1-2 minutes to understand this problem, then we will move to next question. What was our first question? Okay, you people take 2-3 minutes, then we will proceed in a very interesting question. Considering there is no query, we are proceeding for the next question. Question number 5. We have a signal. How it looks like? It is looking like this. This is D2 FT DT2 and this is T. Here it is this is -1, this is +1 and this is -2. Okay, and this value are 1. The question is find ft. Fourier transform of ft. Find Fourier transform of ft. Very interesting question. D2 ft dt2 is given and our task is to find Fourier transform of ft. Can you please try to solve this? Just try. You take 2-3 minutes and tell me the approach in which you can solve this. Just approach. Even if you cannot solve, you just tell me the approach by which approach we can solve this. Take your time and tell me. You take 1 more minute and try to solve this. Can we use the integral property of Fourier transform? Yes. And so our approach will be using integral property of Fourier transform, right? Okay. So first, what we will do? First, we will define dt, d2ft, dt2. D2 ft dt2 is nothing but delta t plus 1 here t plus 1 minus 2 delta t plus delta t minus 1. Okay, so this is delta t d2 ft dt2. Now we will, how can we get the Fourier transform of this? So if we try to get the Fourier transform of this, it is little bit lengthy problem, so keep patience. Okay, d2 ft dt2, its Fourier transform is e to the power j omega for this minus 2 plus e to the power minus j omega. Is this fine? Hope it is fine. Now we will simplify it. How? Can we write it like this? Just rearrange. Plus e to the power minus j omega minus 2 is equal to 2 multiplied with e to the power j omega plus e to the power minus j omega divided by 2 minus 2. Fine. And this is equal to 2 cos omega minus 2. Fine. Okay, let us take some space here. Okay. So how till now it is understandable? Now apply integration property. Now apply integration property. So applying integration property, we will get dft dt. Its Fourier transform will be x omega by j omega. This is our x omega, okay, plus pi multiplied with x0 delta omega. Okay. Okay. So this is x omega. Okay. So we can write it like cos omega divided by j omega plus pi x0. X0 means this will be what? Cos 0 will be 1. So 2 minus 2 is 0. This is 2 minus 2 multiplied with delta omega. So this is 0. So only we have 2 minus 2 divided by j omega. Okay. Now again we will apply integration property. So if we apply again integration property, then ft apply integration property. Ft its Fourier transform is 1 upon j omega x omega means this, right? 2 cos omega minus 2 divided by j omega plus pi into x0 means again in at 0 to minus 2, so by j omega, if omega tends to 0 then we will get 0 delta omega. So we are getting 2 cos omega minus 2 divided by minus omega square is equal to 2 common 1 minus cos omega by omega square. Fine. So this is the solution. This is very lengthy solution. Please take your time, 2-3 minutes, and try to understand what we have done till now. Then we will proceed for the next question. Very interesting problem we have. Please try to digest what we have done till now. Hope you can understand this. Then we will proceed for the next question. It was question number 5, right? Question number 6. First you will try to solve, then I will solve it. Find the Fourier transform of, no, not Fourier transform. Question is the Fourier transform of GT is G omega is equal to omega square plus 21 divided by omega square plus 9. Find GT. It is very interesting problem and easy problem. So you take 2 minutes and try to solve this. If you solve, please say the answer. If you cannot solve, I will solve it for you. Okay, take 2 minutes. The question is the Fourier transform of small gt is given capital G omega is equal to omega square plus 21 upon omega square plus 9. Find small gt. That means the Fourier transform in frequency domain is given, time domain signal you have to find. Find it quickly. Try to solve. The Fourier transform of gt is given g omega. We have to find small g of t. Okay, so I will solve it for you. Given g omega is omega square plus 21 upon omega square plus 9. Can we write it like omega square plus 9 plus 12 divided by omega square plus 9 is equal to 1 plus 12 upon omega square plus 9. Okay, so we have solved in previous sessions that e to the power minus a mod t, its Fourier transform will be 2a divided by omega square plus a square. Okay, so we know, so what we have e to the power minus 3 mod t its Fourier transform is 6 upon omega square plus 9. So 2 multiplied e to the power minus 3t mod 3 mod t its Fourier transform will be 12 omega square plus 9. And what we have that delta t's Fourier transform is 1. So simply what we got, gt small gt is equal to delta t plus 2 e to the power minus 3 mod t. Fine. Okay, so we receive this. Please try to understand what we have done. Then we'll proceed for the next question. It is very simple question. Still you can take 2 minutes. Okay, then next, let's go to the next question. Question 7. Provided that Fourier transform of e to the power t ut is equal to 1 upon 1 plus j 2 pi f. Okay, find Fourier transform of one upon one plus j 2 pi t. Okay, so let us try to solve this. If xt, we know property of duality property. From duality property we know if xt's Fourier transform is x omega, then capital Xt's Fourier transform is 2 pi x omega. Okay, now another thing is if xt's Fourier transform is xf. Sorry, here it is 1 minus sign will be. This is minus omega. Fine. If x is, then capital X is Fourier transform will be small x minus f. Simple. Okay. So we will use this principle. There is two type of duality principle. One is in terms of omega, one is in terms of f. In terms of omega, what is small xt is Fourier transform is capital X omega, then capital X is Fourier transform will be 2 pi small x minus omega. And in terms of f, that means frequency, and omega was angular frequency. If small xt is Fourier transform is capital Xf, then capital Xt is Fourier transform will be small x of minus f. So e to the power minus t ut, its Fourier transform will be given is 1 upon 1 plus j 2 pi f. Right? So 1 upon 1 plus j 2 pi f. Its Fourier transform will be e to the power f minus t, it was, so it will be f u of minus f. So we receive this. Fine. So please take your time 1 2 minutes and try to understand what we have done. Then we'll proceed for the next question. Next question is very interesting. So let us start the next question. Question 8. xt is given. It is very interesting question. is equal to 1 for mod t less than 1 and 0 for mod t greater than 0. Or rather we can write elsewhere. Find Fourier transform of yt is equal to x to t. Convolution x t by 2. Okay. So what is xt here? So we can draw xt like this. It is t xt minus 1 to plus 1. This is 1. Fine. And we know that its Fourier transform will be, if this is, let's write in another way. So Fourier transform of xt will be, we know already, two upon omega sine a omega. A is 1, so omega. Fine. So x of 2t. What will be the Fourier transform of x of 2t? Scaling property, please try to remember. It will be 1 upon 2 omega x omega by 2, that means 4 by omega sine omega by 2, and x t by 2, its Fourier transform will be 2 into 2 upon 2 omega sine 2 omega. What is the value of this? This is 2 by omega omega by 2. What is the value? This is again 2 by omega sine omega by 2. So Fourier transform of yt convolution property will be multiplication of these two. That means 4 upon omega square sine omega by 2 multiplied with sine 2 omega. And here we have made a mistake. Fine. So please try to understand what we have done. Then we proceed in the next question. Next question is very interesting. Take 2-3 minutes. If there is any query, please ask. Take 2 or 3 minutes, and if there is any query, please ask. Take one more minute and try to understand what we have done. Let's go to the next question. Question number 9. Find the Fourier transform Fourier transform of e to the power 3t u minus t plus 2. So can you solve this? Find Fourier transform of e to the power 3t u of minus t plus 2. Try, let it take 2 minutes and try to solve. If you cannot do, I will do it for you. Just try, or tell me the approach in which you can solve this. Okay, let us solve. We know e to the power minus 80 ut. Its Fourier transform is 1 upon a plus j omega. Okay, so e to the power minus 3t ut, its Fourier transform will be 1 upon 3 plus j omega. Okay, fine. Now, if we apply time shifting property, then and shift the time by 2. So what will we get? We will get e to the power minus t minus 3 t plus 2 its Fourier transform is e to the power j2 omega multiplied with 1 upon 3 plus j omega. Fine. Okay. Now let's break it. We will get e to the power minus 3t and here will be u of t plus 2 e to the power minus 6 u of t plus 2. Its Fourier transform is e to the power j2 omega multiplied with 1 upon 3 plus j omega. Let us multiply both sides with e to the power 6. Then we will get e to the power minus 3t u of t plus 2. Its Fourier transform is e to the power 6 plus j2 omega 1 upon 3 plus j omega. Now time reversal property we will use. Then we will get e to the power 3t u of minus t plus 2. Its Fourier transform will be e to the power 6 minus j2 omega 1 upon 3 minus j omega. Fine. So this is the answer. Hope you understand. Now one more last question we will solve. Find inverse Fourier transform of minus a to a 1 x omega omega. Okay. Xt will be 1 upon 2 pi minus infinity to plus infinity. X omega e to the power j omega t d omega. Fine. Is equal to 1 upon 2 pi minus a to a x omega is 1, so e to the power j omega t d omega is equal to 1 upon 2 pi e to the power j omega t by jt minus a to a is equal to 1 plus 2 pi, or rather j 2 pi t e to the power j a t minus e to the power minus j a t is equal to 1 upon pi t into sin 80. Fine. So let us stop today here. Next day we will start again.